Hey y'all, today we are going to talk about analyzing linear equations. So if you haven't already, go ahead and turn in your math textbooks to lesson 2-7. It's going to be page 129. And let's go ahead and get started. A group of college students developed a solar-powered car and entered it in a race. The car travels at a constant speed of 100 miles per 4 seconds. Okay. So that's probably important. Let's underline that information. Now, the car travels 100 meters per 4 seconds. Can we break that down and find out how much it travels in 1 second? How would you do that? Exactly, distance over time. Okay, so the distance they gave us is 100 meters. For every 4 seconds. So how much does the car travel in 1 second? 25 meters per second. MPS, meters per second. Okay, so what representation can show the distance the car will travel over time? How can we show this for any amount of time? We can create a graph. We could create a table. We can also create an equation. Now, we're going to learn about this equation, y equals mx plus b. So, let's go ahead and write that equation down, y equals mx plus b. Now, y is always going to be your outcome, what you're looking for, what you want to accomplish. M, we learned yesterday, is our growth. So for this instance, it would be 25 because this car grows 25 or travels 25 miles per second. So that would be our growth. X is always going to be what you're looking for, how long it takes you to get to a certain place. Or for instance, in last week's lessons, when we were looking for figure 100, you would plug it into X to multiply it by the growth. And then B, we learned last week, that is always your initial value, what you start out with. So this car did not start out with anything because it was constant. It started at 0. What expression can show the distance the car will travel over time? So over time, we know it's 25 miles per second. So we could say y equals 25x, which means I want to know how long this car can travel in, let's say 10 seconds. So I would say 25 times 10, and then y would be your answer. What if I want to know how long the distance is for the car to travel in 20 seconds? Your growth, which is 25, times how many seconds you're dealing with, would equal your answer, and y. Compare the representation and the expression. Which shows the distance traveled over time more clearly? So, what would show more clear if I wanted to know any amount of increments over time or what the car's doing at a given particular second? Graphs are always great. Graphs can show an abundant amount of information. You can scale the graph differently. But what if I want to know an exact moment? You could plug it into your equation, y equals 25x. And you can put that exact moment, that exact second, in and multiply it by 25. Okay, let's flip over and look at a few examples. So, looking at example 1. The students in Meg's class were building a fence around the class garden. How can they use the pricing for different lengths of fence to determine the cost for 50 feet? So, looking at this, we have 6 feet of fencing is $30. 15 foot was $75. And 24 foot was $120. So, what this class decided to do was to create a graph, and they put the length of the fence on the bottom, and they put the total cost here. So they're breaking this down to see how much the fence cost. So we have 15 feet of fencing at $75. This was this data information right here. On this one, we have 25 foot of fencing. Well, it's right before that line, so 24 foot of fencing for $120. You'll notice they have the points there. That was that data information. And here we have 6 foot, $30. So we would go to 6 foot right about here. It would go up to about 30 right there. Notice that is not a perfect lattice point. So what we learned yesterday about our lattice points is you always want to create your growth triangle from those points. We have a point here. That one is not perfect, but this one is. Now, you can create your rise over run. How much did it rise? How much did it run? That will give you your price per foot. Now let's look. They decided to do this over here in step 2. They did this for you. So how much did it rise? How much did it run? So if it rose here, 45, and ran 9, or even rising 130 and running 26, when you reduce that, you're going to find out that Meg and her class can use this equation, y equals 5x. So what you're going to do is you're going to use your growth triangle that we learned about yesterday, and you're going to plug that number in front of x. That's where your slope goes in an equation. So let's see if we can figure out this equation here. The equation of the line is y equals what x? Okay, so they already have one lattice point drawn for us right here. Let's create another lattice point right in front of it. Rise over run. Do not say that this went up 1 block and over 1 block. It did not. You always need to look at your increments. So this went from 60 to 80. So what is 80 minus 60? It went up 20. And over here, it went from a 3 to a 4. So how much is 4 minus 3? 1. So I rose 20, I ran 1, 20 over 1. So the equation of this particular line is y equals 20x. Okay, so let's look at another example. A recipe for trail mix calls for 1 cup of raisins for every 2 cups of granola. Write an equation that describes the relationship between raisins and granola. Okay, so here in this graph, they put granola on the bottom, raisins on the top. So we can create an actual slope triangle to see what is happening. Okay, so there is a lattice point, and there is a lattice point. So how much up and how much over? Notice that this particular graph is going by ones, so you can count your blocks. It goes up 1, and it goes over 2. 1 over 2. So that's how this answer is y equals 1/2 x. Let's look at these. Let's try both of these. Write the equation of the line. So we're looking for lattice points. Notice you have a perfect lattice point in the middle at 0, 0. You have a perfect lattice point here. So how much up and how much over did this go? Let's look at this problem. Go up and over. Notice that this graph does not go by ones. So you do not want to say it went up 2 blocks and over 2 blocks. It did not. It went up to 4. From 0 to 4 is 4. And to get from this line, your y-axis is always 0. To get from 0 to this dot, which is on a 10, how much over did it go? 10. So y equals 4/10 x. Now, is this in simplest form? No, it is not. You can reduce that. So the most simplest form is y equals 2/5 x. This would be your answer. So you're using what we learned yesterday, the slope triangle, to create an equation now. Let's look at the next page. The equation for a proportional relationship is y equals mx, where m represents the slope of the line. So looking at this line right here, you would want to find lattice points, and you would want to see how much it rose, how much it ran. So it shows you on this example, it rose 4, it ran 1, so y equals 4x. Now, go ahead and try the do you understand and do you know how, and check your work with mine. Once you're finished with that, you can look at your practice and problem solving, front and back, and check your work with mine. I hope this helps. Y'all have a great day. Bye.